Okay, I think we're ready. Welcome to the third webinar in our webinar series, March to Open Access. We are on our path to open access, which is happening this summer, when anyone can use our network and create accounts on it. The first webinar was on the path to decentralization, how we get from where we are to being a totally decentralized permissionless network and how to be secure at every point along the way. The second webinar was on how to be stable, how to have a stable ledger in a world that is very unstable, where every ledger is forking all the time. How can we bring stability and ensure that it will not be forking, not have a forking of the state and other things? And we talked about that extensively last time. Today is webinar number 3. It is introducing a new service, the Hedera Consensus Service. This is a new service that we're offering, in addition to the 3 we already had. It is also a new kind of service. It is unique in several ways, and so we will talk about what the Hedera Consensus Service is and how it's useful. But it opens up a whole different kind of world of things you can build on the network. We'll talk about that. And then we'll continue. There'll be future ones, like maybe the next one will be on unique aspects, unique features of Hedera Hashgraph. So if you remember last time, what we talked about is that stability is very important, and that there are multiple ways that we can try to avoid forking. We do all of them. Anything we can think about that would bring stability, we're doing it. And many of those ways ended up depending on the state proof. It ended up being a theme. And we finished by saying we are absolutely committed to being stable, to not having forks, to providing people the stability that they want and that they need for some applications. You really need the stability. That was what we talked about last time. And the main points were simply that state proofs are the key to all this. You can prove that the network did something that is telling you the truth. No single node can lie to you. And it turns out that's a key for today too. State proofs just end up being important across the board. And so that is part of our commitment to no forks. But on to today. Today, we are talking about the Hedera Consensus Service. The Hedera Consensus Service is a new service, and we've written a white paper about it. I wrote it with Donald Thibault and with Bryan Gross. Now, Bryan Gross is Principal Product Manager for IBM Blockchain platform. He's at IBM. He co-authored this paper with me, and we will even be hearing him later today. Hi, Bryan.
Hi, Leemon. Good to be here. I'm excited about today's webinar topics.
It is great to have you here, Bryan. I appreciate you being here. Thanks. So we'll get to him a little bit later. And we'll also give you the URL again later. You can go to Hedera and get this white paper. This lays out this new service, this new kind of service, this unique service. You'll find out about that, and you can get all the details there. So what are Hedera services? What does that mean? Well, for any ledger, for our ledger included, you have the bottom layer, which is the Hashgraph consensus layer. This does the consensus, which means it puts the transactions in order and gives each of them a consensus timestamp. That is what it does. Then you have the layer above it. Those are the services. The cryptocurrency service, smart contracts, files. And they do the actual logic of what has to happen. So when you have a transaction to move cryptocurrency from one account to another, the cryptocurrency service actually does it. Now, of course, it has to have the lower level, putting them in order, but once you have them in order, it's easy to write a service like the cryptocurrency service. So we wrote a service to let you do cryptocurrency. And there's a service to run smart contracts, and there's a service to store files and to ask what's in the file and all of that. And so they are a layer on top of the consensus layer, and that is our public ledger. It is managed by the Hedera Governing Council. They govern it, they rule it, they decide where it's going, they decide what features go in, they decide on code upgrades, they manage the treasury of all the coins that have not yet been released, that are still part of the cryptocurrency service that haven't been released yet. There's a total of 50 billion. Most of them are sitting in treasury. They manage all that. And then on top of all this, you have the third-party applications. That's where the real value is. And we have hundreds, over 500 have already talked to us that they're going to be there. We have a bunch launching on day one. We have others that we haven't even talked to. These are little independent developers and gigantic corporations and medium-sized people and people that want to use us, consortiums. All sorts of people are building these third-party applications, which then give the real value to the end user. And the end user is individuals and enterprises and governments and even devices. It could be IoT, Internet of Things. Even things can be end users of the system. So this is what we have. We've had this chart for a long time. This has been the structure for a long time with the 3 main services: cryptocurrency, smart contracts, and file service. And at the very bottom layer, of all this, the Hashgraph consensus layer, is important because everything else relies on it. And it is ultimately secure. So it is asynchronous, Byzantine fault tolerant. That's the best security that you can get. Asynchronous means it even works when there are partitions and slowdowns in the network and malicious nodes, and maybe partitions that completely partition the network, just freeze us, but partitions that are malicious and let some packets through and not others, and slow down some and not others, will not fork us, will not interrupt our consensus, and if we're talking to each other at all, we'll continue making progress. So it is the highest standard you could have in a consensus system is asynchronous Byzantine fault tolerant, ABFT. And so we want to leverage that. And so all of our services leverage that. Anytime that you have a service that is using the core underneath it, it gets the asynchronous Byzantine fault tolerance property. So our cryptocurrency is ABFT. Our smart contracts are ABFT. Our file service is ABFT, which is nice. And for some cases, you need it. In addition, we have fairness. Almost no one has fairness. I'm not even aware of any major ledgers that have that, in that no one node gets to organize the ordering of your transactions or gets to decide if it's going to leave out a transaction. The best that you'll see elsewhere is, well, we take turns being the boss. It's whoever mined the latest block, or maybe we have a round robin where we take turns, or maybe even randomly decide who does the next block. But even then, whoever does that block gets to decide which transactions go in and which don't. And whoever does that block gets to pick the ordering in it. And if several blocks in a row decide not to put in your transaction, you're out of luck. We don't have that. We have fairness. You're guaranteed that when you submit to the network, when your message reaches the network, it's going to end up in the right order with all the others based on when they reach the whole network. Period. No one node can stop this. No one person can stop this. We don't ever have a boss or a leader or a king. Not even for a moment. It's leaderless. And so we have this fairness of the ordering and the fairness of the timestamps, because the timestamp is when you reach the whole group. It's the median of when they all say they got it. So it's a very fair form of timestamping. You even have fairness of access. Because there's not just one miner that gets to pick what's in the next block, or one leader or coordinator or whatever proposer that gets to pick the next block, then there's no one person that can delay you a block. When you give your transaction to one of the nodes in the network, as long as it passes it on, there's nothing else it could do to hurt you. No one can hurt you. And what if it doesn't pass it on? You can give your transaction to several nodes, and whichever one reaches consensus first will count, and the others will just be ignored. So if you want to, you can actually even eliminate the problem of a node just ignoring your transaction you gave it. So we have fairness of access. So ABFT and the three kinds of fairness are something that are unique to Hashgraph, and therefore unique to the Hedera Hashgraph ledger. Why did I talk about all that? Because they are inherited by the services, which is important. So our three services, the cryptocurrency, the smart contract, and the file service, inherit these properties of being ABFT and having fair ordering and having fair timestamps and having fairness of access. This is important. If you do something important in your smart contract, you know fairness of access. It'd be very, very hard for an attacker to prevent people from getting to your smart contract. If you have a file, it's very hard for an attacker to prevent people from writing to the file or reading from the file or whatever. So then you have really two implicit services that are sort of implied by these three. Timestamping, putting timestamps on the things, and revocation, the ability to take things back out that an authority has attested to. So the timestamping is not a separate service, but every time you do something, every time you create a file, it gets a cryptographic timestamp, and all of the members of the network agreed on it. It's the consensus. It's a very strong kind of timestamp, not just one computer making it up. It's the whole group making it up together. And it isn't just one making it up and then everyone approves. It's everybody saying what time they received it and then taking the median. So it's a very strong kind of legally binding timestamp. And if you're legally required to publish something by noon on Tuesday, you put it in the file service and you get that timestamp and it proves you did it by noon on Tuesday. In a lot of ways, it's like a cryptographic timestamping service, where if you have some document, you give the service a hash of it and they give you a cryptographic timestamp on that hash. Do the same thing here. Just put a hash in our file and you have it. Or put a hash into a cryptocurrency transaction and you have it. And so it's not a separate service, but it's sort of something you get for free out of these three services. You have a timestamping service. Similarly, we have a revocation service. It's sort of implied because of the way we do keys. So if you create a file, you can of course have a key on it, or you could have a threshold key, which is 3 out of 5, say. Any 3 of these 5 people can sign to delete the file. But if you want to, you can also do it where you have, say, 2 keys, and both are needed to put the file in, and only one is needed to take the file out, to delete it. In other words, it could be some kind of a certificate, or a hash of a certificate, or a hash of some claim about you, maybe your driver's license or a diploma. It could be a hash of it, and both you and the authority have to cooperate to put it in. So you agree that you want this hash to be put in there, and the school or the DMV or whoever gave you the certificate has to agree to put it in. And then, if it's ever revoked, the other party can take it out, or if you ever don't want to have it anymore, you can take it out. Either of you can take it out. So it's not the same as a threshold key, because when you put it in, it's a 2 out of 2, and when you take it back out, it's a 1 out of 2. That's not a separate service, but it's an incredibly powerful thing that you get that's just a part of our file service. It's also a part of our cryptocurrency service. We have live hashes attached to accounts, which have the same deal. Both keys are needed to add it, and either key can take it back out. So revocation and timestamping are 2 sort of implicit services that also are built into these services. Just kind of they come along, woven into the 3 existing services. Now, with these services, you have smart contracts. Smart contract is a native service of our platform. Then on top of that, you build your various smart contracts, and you can build as many as you want, and they can do anything. They're written in a Turing-complete language. It means they can do anything. But of course, they run more slowly than a native service would run. For example, we have the native service of cryptocurrency with the H bars. But you could also write a smart contract for an ERC20. And the ERC20 is doing the same thing as a cryptocurrency. But the native cryptocurrency is going to be faster than the smart contract, much faster. We can do thousands of cryptocurrencies per second. We're going to have, I think, 10,000 probably at launch, at OA, I mean. We'll throttle it down to 10,000. It's much faster than that already in our test nets. And we are working to tune it. It'll be many tens of thousands. So the cryptocurrency is fast. Smart contracts are slow. They're a few a second. They're not very many. And so you can do anything in a smart contract, but it's not the same as a native service. And every ledger has this issue. Smart contracts, now some of them emphasize smart contracts and make them faster, but still a native service is faster. And so every ledger struggles with this question: what should we make to be our native services that give you all the advantages over just running a smart contract on top of a service? And everyone has to make that decision. But we would rather you make that decision. We would let you make that choice. And here's how. We're offering a 4th service now, native service called the Consensus Service. The Consensus Service, of course, is fast because it's a native service. And what it lets you do is build what is equivalent to new services. And I say you, developers, without talking to us, without us even knowing about it. Just like you can write a smart contract without talking to us. You can write your own service without talking to us. And your service lives on top of the Consensus Service. And your service runs at the speed of a native service. That's interesting. The perennial problem in ledgers is, what do we pull down into the native layer and what do we just leave as smart contracts? We're now letting anyone pull something down to the speed of the native layer anytime they want, just by building on top of the Consensus Service. It's a lot more work than a smart contract. So a Consensus Service is harder to build than a smart contract. You have to do more effort. You have to get other computers involved. But you get the speed of Hedera Hashgraph itself, of a native service, and you get the security. Just like a smart contract inherits ABFT and fairness of ordering and fairness of timestamps and fairness of access. In the same way, if you build a service on top of the consensus service, your own thing runs at the speed of a native service, and it's ABFT. And it's fairness of ordering and fairness of access and fairness of timestamps. Your service gets all of those properties. And when I say it's ABFT, of course that means you have to trust more than 2/3 of the nodes. You only have to trust more than 2/3 of the Hedera nodes. You don't actually have to trust the other people that are using your little service or the computers that are making up your new service, your thing that you're building on top of the consensus service. You don't have to trust them. You don't have to have 2/3 of them being honest. It isn't like a side ledger or a side chain or a layer 2 thing where you have to have extra trust in these side people. No, you inherit the trust of Hedera. That is the consensus service. It is a new service we're doing. It's a new kind of thing. And it's really allowing you access to the core Hashgraph consensus itself. It's letting you reach down through these native services into the core engine itself and gives you access to the core engine itself. That's the new service. So I mentioned side ledgers, and then there's sharding. There's all these different ways of scaling things up. Let's go through them because they're very different from each other. There really are fundamental differences between these different kinds of things. You have sharding, you have side ledgers, you have this consensus service. As I said, it's unique. It's a different kind of thing than you have seen elsewhere. It's not a side ledger. It's not a shard. It's not just a fast main ledger. It's not another main net. It's not our mirror net. There's yet another thing. It's a different thing of its own. So let's talk about what the differences are. Sharding is when you take your big network and break it up into groups. So here we have 2 different groups of nodes that you can see on the screen, 2 different shards. And the idea is that the information, the source of truth, the official information ends up being split up across the shards. So for a cryptocurrency system, maybe the balance that Alice has in her account is something that is in one shard along with Bob's balance, but Carol's balance is in a different shard. And then when Alice wants to transfer, if she wants to transfer to Bob, she tells just one shard. The shard does it. Only one shard has to be touched. That's why you get a speed up. And the information is only stored in one shard, so you have better scaling on what you're storing. And the other shards don't even have to know about it, so they're much faster. But for trust, you do have to trust all the shards. Furthermore, if Alice wants to transfer to Carol, then actually her shard, that shard, has to talk to the other shard. The 2 shards have to convince each other they're saying the right thing. State proofs again. And then they can do it. The first shard removes it from Alice's balance, decrements her balance. The other shard increments Carol's balance. And they can trust because of the state proof. And Alice can trust that the whole thing works as long as more than 2/3 of the members of every shard are honest. So we have good trust. Assuming you can trust Hedera to be more than 2/3 honest, we can have good trust. You don't have any privacy here. Everything's visible to the whole universe. That's sharding. On the other hand, you have side ledgers, side chains, layer 2 stuff. Here, the ultimate source of truth all lives in the ledger. So on the right side here, we have the main ledger. The ultimate source of truth lives there. And then over on the side, you have people, Alice, Bob, and Carol, and maybe they have computers that talk to each other. And so they're constantly talking to each other on the side. It's sort of a network. Maybe they even have their own kind of chain. Maybe they have some kind of a layer 2 thing where they're all talking to each other. And they're doing transfers back and forth to each other, not touching the single source of truth, which still belongs to the main ledger. They're just talking to each other, and then periodically they'll send a summary over the main ledger. So you can imagine Alice and Bob sending information or sending, say, their tokens back and forth to each other for a long time, and then at the very end, they both agree, okay, the net result is Alice gave 1 coin to Bob. And so then the summary is, finally, transfer 1 coin from Alice to Bob. Great. This also gives you speed. In fact, a lot of ledgers depend on side ledgers for their speed, or layer 2 things for their speed, where lots of transactions happen off ledger, and then occasionally you get a summary. So that is good for speed. It isn't so good for it's okay for privacy because the summary is visible to the whole world, but only the summary. It's not perfect privacy because the whole world still sees that ultimately Alice sent one coin to Bob. But some of the details are hidden. At least all those little transactions between Alice and Bob you don't see. The trust isn't as good though. You're going to have to trust things over on that side. So if Alice and Bob are going to record their summary, they have to trust each other to not just stop in the middle of the day and not do the summary. So they kind of both have a veto over that summary. Or they can't summarize every transaction because then there's no advantage to the side ledger. So you don't have the good trust. Or maybe they just all trust Bob to do the summary and he signs it by himself, but then you all have to trust Bob. So trust isn't so good. With the consensus service, here's how it works. We talk about a single source of truth. That's now over on the side. If you're creating a service to do something, you get to have the store of the truth. Alice, Bob, and Carol are all storing this. There's no balances in this example. So here's, say, maybe it's a stable coin. Maybe the example here is a stable coin. And so Alice and Bob and Carol all keep track of how much of the stable coin they have. Notice the main ledger doesn't have that. Great for privacy. Great for storage. We're not going to use up memory on the main ledger. It's all on this side ledger. Okay, well, you'd say, well, then I'm sorry, I said side ledger. Well, in a side ledger, what you have to do is occasionally anchor it maybe in the main ledger and put a hash in the main ledger. But then you still have to trust them in various ways. We don't do that. Here's what we do. They can do their transfers between each other by sending an encrypted message to Hedera saying, okay, Alice is transferring to Bob. They're not talking to each other. They're talking to Hedera. The single source of truth, the information, is stored over in their side thing, in their new service that they're building themselves. But all their messages, all their transactions, everything they do flows over to the main network. They're encrypted. The main network doesn't know what they mean. The main network then does what consensus engines do. It puts them in order and it puts timestamps on them. And then it sends them all back to Bob, say, with a proof of state. Bob will also have a state proof and a timestamp. So it is a state proof for both the order and the timestamp. All of those messages come back to Bob with a proof that they're in that order and they have that timestamp. Bob can then go ahead and send them to Alice and Carol. So Alice and Carol have them too. They know he's telling the truth because he gave them that proof. And now they can also know that Alice sent Bob the stable coin, say. And so they can all keep track of what the balance is here. You know, what they're doing is the logic that you would do in a ledger. But the trust model is totally different. They don't have to trust each other. They don't have to have 2/3 of Alice, Bob, and Carol being honest to be trustworthy. Any one of them can take this list of messages and the state proof and go to a court and say, these were the messages, this was the state proof. Hey, court, you can rerun the logic yourself and you can see, yep, at the end of the day, Alice should have ended up with 10, Bob should have ended up with 20, and Carol should have ended up with 30. And at the end of the day, that's what it was. And any outside auditor, any outside legal authority, any outside arbitration authority can look at it and know that it's true. Interesting. It's almost as if Alice, Bob, and Carol had their own ledger, had all the speed and scalability of their own ledger. They store their own information, but they have the trust of Hedera. The consensus engine in Hedera is being exposed through this consensus service and is allowing you to get all of the trust of Hedera into a small private network where you really don't trust everybody. You really don't trust more than 2/3 of Alice, Bob, and Carol are going to be honest. You don't have to. That is how the consensus service works. And so we end up then with very good privacy. The main ledger never even knows what balances they have. In fact, the main ledger never even knows that this example was a stable coin, was the example. The good ledger provides its trust, its level of trustworthiness to the whole system. And so it has the trust of the main ledger, but the privacy of a private ledger. And that is the best of both worlds. Plus, the information doesn't have to be stored in the main ledger, so it's very cheap. The main ledger just has to put these transactions in order. Really, you're just taking advantage of the consensus engine. And you get all the advantages of the consensus engine. And so is this ABFT? Yes. Is it fairness of ordering and of access and of timestamps? Yes. All of those benefits come in. And so we've heard about people coming out with new stablecoins and social networks doing it, but what if some other social network wanted to do it? They could do it this way. And you get all the trust and all the speed of Hedera, and it would be ABFT, and it would have fairness of ordering. All of that. And yet it's very scalable. And you have total privacy. Privacy is a good thing. We really do want to make it possible for you to have privacy. With this, you can have privacy. And so that is how it works. Now I said a stablecoin is a use case. Sure, that would be a use case. What other ones? You have a stock market. In a stock market, you want to make sure that your bids and your asks, your bids and your bids, when people are bidding on a stock, that it's fair in the ordering. You really need fairness of ordering for a stock market. And you don't want it to shut down. You really need ABFT to make it hard for people to DDoS it, to do a distributed denial of service attack and shut it down. You really want to make sure of that. And it is private, possibly. Stock market isn't private. Maybe a dark pool is private. If you wanted it to be private, you could do it, where all you have are these encrypted messages flowing through Hedera, but Hedera doesn't know how many shares anyone owns. They don't know what these messages mean. They don't know what's going on. Everything is hidden. You can even hide who's talking to whom. It can be very hidden, and very good privacy. Or even simpler, how about an audit log? In an audit log, all you do is you have something going on, some process. Maybe you're shipping pharmaceutical chemicals, you want to make sure they're good, or shipping foods, you want to make sure they're good, or you want to, you're just a bank and you're doing transactions, you want to keep an audit log to show that you're doing the right thing, or you're just any company that has to keep the books, and you have to show the IRS, and you want to have an audit log. There are various industries where it's required to have an audit log. So what do? You send everything you do to a hard drive somewhere. Eventually, maybe it ends up on tape. And if an auditor comes, you hand them the tape and you say, trust me, I never changed it. Not ideal. People could go back and change the audit logs. With this, though, you just send all those messages encrypted to Hedera, or hashes of all those messages, that would work, to Hedera. Hedera puts them in order and puts the timestamps on them. And then when they come back to you, store all of that on your hard drive, and eventually it goes to a tape. And when an auditor wants to see it, you hand them the tape. They see everything you've done, and they see the state proof from Hedera that says, yep, these messages, or the hashes of them, these actions you did, or the hashes of them, are true. And the full weight of Hedera is behind it. And you'd have to corrupt a third of Hedera's nodes in order to corrupt your audit log. It's strong belief in the audit log. So we could do that. Or you could use it for games. Same thing, transferring assets in the game, or even how the game went and how it went. You need the stablecoin we talked to. The games themselves might do stablecoins. Lots of places for it. So that's it. It's a new kind of thing. It's sort of like a shard, sort of like a side ledger, sort of like a layer 2 thing, sort of like a mirror net, which we haven't even talked about yet, but not exactly like all that. It's a new kind of thing. Really what it is it's exposing the underlying consensus engine and putting on top of that all of the trust of the nodes of Hedera, and putting that behind something you run on the side that's really independent. And it does not have to anchor in the main network. It does not have to store the single source of truth in the main network. It doesn't have to pay for any storage in the main network. It's all just happening over on the side, but you get all the trust and the ABFT and the fairness of the main network. That is what the consensus service is. So what were all the concepts? Well, we talked about the messages, which can be encrypted. We talked about privacy. Because they're encrypted, they can be private. We talked about messages with privacy. I just said you can encrypt them. I also mentioned you could use a hash. You really have lots of choices. You could send the messages plain text through Hedera and let the whole world see it. Maybe you want the whole world to know that you did certain things at certain times. Maybe that improves your reliability. So you want your messages just to be plain text. Or maybe you encrypt them all with a key that the 3 people in their little network over here have, that Alice, Bob, and Carol know. And so only they can read it. Only they can create the messages, only they can read it. A single symmetric key. Or maybe even a key pair. Any of them can create message, or any of them can read it, but only some of them can create messages, or whatever. You can divide it up as you want. That gives you privacy. Though maybe you're afraid that people recorded the messages, and then if I ever leak my key, all the old messages will be visible. That's a concern. You know, there's better things you can do. You could say, well, I'm so concerned about that, I'm just going to send a hash to the main network and then just spread out the real message within Alice, Bob, and Carol, just locally gossip it around. Well, you could do that. The only problem is if Alice submits a hash to the network but fails to gossip out her real message, then if they ever have to go to court, Bob can say, well, yeah, I saw Alice's hash, but she never gave me the message, so I don't know what it is. And Alice would say, well, I did give you the message. And there's no way to prove it. So maybe hashes aren't the best way. And you could say, well, maybe we'll do some signatures or Bob gives receipts, and you can work out a system, but it's complex and there's some downsides. Or you can go to something simple and use Hedera to solve the problem. You could simply encrypt every message with a symmetric key that is simply a session key, a short-term key, one that just lasts for a few seconds. And so it goes out to Hedera, it comes back within a few seconds, everybody reads it, everybody gets it, everybody knows it, and then everybody switches to a new key. And everybody throws away the old key. And so then in the future, if your computer gets hacked and you lose your key, all those old messages are still secure. And so you have perfect forward secrecy. If there are people who've been listening to the mainnet, they're not going to be able to recover from the past. That's probably the best way to do it. And so what you would end up sending to the network is your encrypted message and the hash of the plain text, and then over on your main network or on your whatever the thing is you're doing by yourselves, you all spread around the plain text message, and you all can decrypt to get the plain text message, and that's what you store on your hard drive with the hash. And then you get the state proof proving the hashes were right. Anyway, that's the grounds for a whole other one of these webinars. We will talk about that more in detail. All I want to say right now is that you not only get the full trust of Hedera behind what you're doing, but you can be private. You can keep it private, as you might want to keep things private. We also have mirror nodes. I've mentioned them a few times. Mirror nodes are a way that a computer can know everything happening on Hedera, and people can do it anonymously. You don't have to sign up with us. You don't have to tell us who you are. It can be all anonymous. You can have millions or billions of people around the world. They can't hurt the network. They can't hurt the security. They can't slow it down, but you know everything that's happening. So in this example, I always said Bob knows everything that's happening. All these messages are coming to Bob. That's a way of doing it. We could also have just had Alice and Bob and Carol all receive the message. They could all run mirror nodes. Or just a few of them could run mirror nodes, and you just have to trust that at least one of them hasn't crashed. The mirror node can't lie because of the state proof. That's a good thing. But the mirror node could always crash and not be able to pass things on to you, so maybe you have several mirror nodes. Or everyone runs a mirror node. By the way, if you run a mirror node, you don't even need state proofs from these other guys. You just know the truth yourself because you do all the calculations that the mainnet does. So you know the truth. You don't even have to worry about state proofs. You can create state proofs for other people. There will be a running hash on these messages within a topic. We'll talk about that in a second. But basically that ties them together. And so you will easily be able to store all these messages on your hard drive and later prove to an auditor that none are missing and none were modified. All you need is a state proof on the very last one, and the running hash verifies all of them. And it's the state proof I keep mentioning is how you know this is true. As long as you know the ledger ID of the main ledger, you can be guaranteed that it is true. You can check the state proof and know that it's true. We had another webinar on that. You can see that webinar for that. Topics. I mentioned topics a second ago. So when you submit a message, you submit it to a topic. And a topic might be an ID number like 001234. And then Bob could say, I'm going to pass on to Alice and Carol only the messages from my topic. Maybe this stock market, this stable coin, this game is topic 001234. And we really don't care about all those other messages that are flowing through Hedera. And so gazillions of messages are flowing through Hedera, but it's only the ones relevant to this group that are flowing then to Alice and Carol in this example. And those are the only ones we have to store on the hard drive. The running hash is only for those, so the state proof proves those. You don't have to worry about the rest. So that's what a topic is. And then, of course, the question is, well, how do you build this sort of thing on the side that we've been talking about? Well, you can build it from scratch. It's a lot of work. I told you it's harder than a smart contract, but you can do it. Or you can use a framework that makes it all easy to do, that adds lots of pieces for doing it. Hyperledger Fabric. allows you to build this whole thing and easily and manage it. And it gives you the ability to connect a bunch of computers and to manage a dashboard of who the computers are and how they talk to each other and to set up the logic and all of these things. Hyperledger Fabric lets you do that. And so you can do this, and your little group has all the privacy of a Hyperledger Fabric private network, but you've got the trust of Hedera itself. You don't have to trust that more than 2/3 of your private people are trustworthy. And so you're getting the best of both worlds. And Fabric and Hyperledger have a million tools to help you do this more easily and do this better. And so to give you a better introduction to that, I am really excited that we have Bryan Gross here. Bryan Gross is Principal Product Manager at IBM, and he will now say a few words about how would you do this? What are the use cases for this? So go ahead, Bryan. Please tell us more about this.
Thanks, Leemon. So my name is Bryan Gross with IBM Blockchain, where I'm a Principal Product Manager for IBM Blockchain Platform, the leading platform for building, operating, and growing enterprise blockchain networks. For IBM, blockchain started in mid-2015 when clients really began asking us our opinion on blockchain and whether or not they should get involved in it. So we did some exploratory work and got really excited about it, but unfortunately we're not able to find a distributed ledger technology that was compatible with the requirements of business, primarily things like privacy and confidentiality. And that led us to start prototyping something that became known as Open Blockchain. And we donated the code, development resource, and intellectual property to the Linux Foundation Hyperledger project in early 2016. This early adoption and insight into blockchain by IBM has helped us become the recognized leader in blockchain for business. So our platform manages over 1,200 blockchain networks around the world. And more importantly, over 100 of these networks are live, creating blocks on the chain every day in real business processes with actual business partners. I'm going to give you a couple of examples. The first is TradeLens, a Maersk and IBM partnership which is focused on containerized shipping. It connects the entire supply chain ecosystem to share visibility into container shipments so that you can increase the speed and transparency for cross-border transactions and reduce cost and increase efficiency through paperless trade. The second example I want to call out is IBM Food Trust, which is an ecosystem involving farms, distributors, retailers, and consumers in order to help address the fact that 1 in 10 people are sickened and over 400,000 fatalities occur worldwide every year because of foodborne illnesses. In this case, blockchain is used to create this connection of shared value across all of these participants and provide traceability to improve food transparency and efficiency. And those are just two examples. In the financial services sector, the public sector, retail, insurance, and manufacturing, there are hundreds of more use case examples, and we're still in the early days of understanding the potential. You can learn more about these use cases by going to ibm.com/blockchain. But today, let's start talking a little bit about how they go from concept to consortia to running network, and where in this process the Hedera Hashgraph Consensus Service can help. So I mentioned that the IBM Blockchain platform is powered by Hyperledger Fabric. But one thing I want to call out is that Hyperledger Fabric is a framework or a toolkit, but it's not a running network like Hedera. It doesn't provide running services like the 4 services mentioned earlier by Leemon. So in order to get value from a Hyperledger Fabric network, a network operator must deploy nodes, start or join a network, and install and substantiate chain code. Now in this process, that network operator relies on 3 Fabric components because Fabric is really built in this modular way where you can swap in and out these different components to meet your use case. The first component is a certificate authority that identifies organizations that participate in the network. The second component is a peer, which can represent your organization on the network. This peer can endorse transactions and run the network. But the third service, which is the one that's most interesting today, is the ordering service. And this service is the one that determines the fair order of transactions. Now, just to review, network operators do not have a lot of problems with CAs or deploying peers. Their use makes sense, and they need these components in order to provide the controls they need over their enterprise data and business logic. However, the ordering service can take some more time to understand, add some complexity in deploying, and is really where you need to make decisions like who's going to run the ordering service, how many nodes will I operate, and which consensus algorithms will back this order of transaction processing. And there are real performance and cost implications to these decisions. And as a result, Fabric has implemented 3 options today for ordering. The first is solo. So this is really an ordering service for developer purposes because it's not crash fault tolerant, but it is easy to set up and it's high speed and low cost. The second 2 are crash fault tolerant, but are not Byzantine fault tolerant today, like discussed by Leemon earlier in this webinar. Now, Byzantine fault tolerance is on the Fabric roadmap and it will happen, but even when it does, you need to recruit people to run those nodes in order to have that property of not trusting any one person to operate the node or order the transactions in a fair way. And so we think that enabling another option through this partnership with Hedera, where network operators can access fair message ordering by 39 major companies without going through the effort and expense of deploying 5 RAF nodes or forming a consortium or running their own nodes, is potentially something of value, and we'd really like to hear from you if it would work well in your network. Let me talk a little bit about how this could function. First, the client broadcasts messages to the Hedera node. These events are then gossiped between the nodes, calculating the consensus timestamps and generating state proofs, and they can remain private this entire time through encryption as discussed by Leemon earlier. Then, this published order will go back to the registered peers in Fabric, and the peers can register with one or many of these mirror nodes and then notify the client of the fair consensus order. So again, without owning your own components or recruiting companies to run the components, you can get this Byzantine fault tolerant consensus service from Hedera to help you order your transactions. We have created a white paper. We're really seeking feedback on it. We're going to provide a link to that later in this webinar. But please let me or Leemon know if you have any questions. Back to you, Leemon.
Okay. Well, thanks, Bryan. That was great. So, yes, this is what we can do with Fabric, or what you can do, I should say. You, as developers, can do with Hyperledger Fabric to be using this consensus service. And look in the white paper. Bryan and I wrote this white paper, and I think it lays out more details. And stay tuned for more information coming from us about it all. But I'm very excited about it. And Bryan, I really appreciate you joining today and being able to explain all of that. That was fantastic. So what's the summary? Well, the summary is, if you want to do something like this as a developer, you develop it, maybe use Hyperledger Fabric to do a lot of the work for you, and you develop this thing on the side, and then with Hedera, you create a topic, and you create a new topic just like you'd create a file. You create a smart contract, you can create a topic. Very cheap. Now you have a topic ID. You start up a mirror node, or find somebody else who has a mirror node that's willing to stream things to you. Maybe don't even stand up your own. It's a third-party company that does this. There'll be companies perhaps that do nothing but stand up mirror nodes and stream out messages coming from the consensus service. I could see that actually as being a big company. They could make their money selling streams of messages to lots of different people where each person is only subscribing to one of these topics. And so amortized, it becomes very cheap for each of them to subscribe to one stream. And the mirror node can make a business of doing that. And anybody can do that. You don't even have to talk to us to start up a business doing that on a mirror node. Then the clients themselves, the people playing the game, submit their messages to Hedera. The people transferring their stable coins submit it to Hedera, or the people doing the stock market submit their messages to Hedera, possibly encrypted the right way, possibly just hashes of those messages. You can talk about what security you need for your system. But whatever they do it to get the amount of privacy they want, the amount of security they want. And then it all comes back, and so you can have third parties validating your state proofs. So third parties can look at your state proof and know that you're telling the truth about what happened in your system over here. And so your system has the security and it has the speed, and then it has the reliability with third parties. And they can know you're telling the truth. As long as they believe that Hedera has more than 2/3 honest, they know you're telling the truth. They don't have to believe that you're honest. They don't have to believe that your little system over here, your game or your stock market, has more than 2/3 honest. If you're playing a game, probably not a good assumption they're more than 2/3 honest. Probably a better assumption that they're all dishonest. Who knows? But you don't have to trust. You get the enormous trust of Hedera, even if your small system is not trustworthy at all. You still have that trust because third parties can validate the state proofs. Then there are multiple participants running mirror nodes. I said you can have one. Maybe not even someone in your group, maybe just some third-party company. Or maybe you hire several third-party companies. By hire, subscribe to a stream. Or maybe several people in the group themselves run mirror nodes. Maybe everybody runs a mirror node. If you do that, you don't even need state proofs. You just all know the proof or know the truth. And when you store it to your hard drive, maybe you create state proofs and store them on your hard drive. Privacy, of course, comes through encryption or through hashes. It can be simple encryption or it can be encryption with keys changing by key agreement protocols. I won't go into the detail of how those work to give you ephemeral keys for perfect forward secrecy, but this is all well-known stuff. Whenever you go to a website that says HTTPS, it knows how to do all that stuff. TLS knows how to do perfect forward secrecy, unless the website forgot to check the box to turn that on. Websites sometimes do that. But most goods websites check the box to turn that on, and they have perfect forward secrecy. Well-known, understood stuff. You can make your keys be changing. They involve talking to each other. You have to send messages to each other, except you don't have to send messages to each other. They can be part of the messages going through Hedera, or the key agreement themselves. Use the current key to agree on the next key. And even if you eventually lose the current key, nobody will be able to figure out what the next key is. It's just beautiful. You can actually do really good things here. So we can have privacy of whatever level you want. Not hard to implement that. What's hard to implement is a whole network of your own with computers and things and logic running. But that's easy if you're using Hyperledger Fabric. And so Hyperledger Fabric is the way to make that easy. Those are the typical steps. I encourage you to get more information from the white paper. Hedera.com/consensus is where the information is. You can read this. Bryan wrote this with me. I was really happy to have him joining us with this. This is just great working with him. And tells you more about it. And we'll be giving more information in the future on this. So thank you very much. Thank you for joining us for this particular webinar. Thank you for joining us for this whole series. Thank you for listening to us. Thank you for reading this paper if you do. And just thank you for all the ways you've been getting involved. Have a good day, and I hope to see you at the next webinar.